In a world where desk space is a premium, the traditional computer tower can seem like a relic of the past. Enter the Mini PC, a marvel of modern engineering that packs the full power and versatility of a desktop into a compact, elegant chassis that fits in the palm of your hand. From powering a home office or a sophisticated media center to handling everyday computing tasks with ease, these small but mighty devices are redefining personal computing. But how is this powerful technology crafted from raw materials? The process begins inside the company's design and engineering office, where the mini PCs are conceived. A hydraulic press stamps a flat aluminum disc, performing the initial deep draw that forms the basic shape of the computer's casing. In subsequent stages, other presses trim the excess material and further refine the casing's dimensions. The factory floor is lined with rows of computer numerical control, or CNC machines. An operator secures the raw metal casings into a custom jig, preparing them for precision milling. Inside the machine, a high-speed milling tool, bathed in coolant, precisely machines the outer surfaces of the casing. After the milling is complete, compressed air blows away any remaining aluminum shavings and coolant. Workers then carefully apply a protective film to the freshly milled surfaces to prevent scratches during handling. The casing returns to a CNC machine, where the interior is milled to create the precise mounting points for internal components. In a dedicated polishing area, a skilled worker uses an orbital sander to smooth every surface and round the edges, creating a flawless finish. The meticulously polished casings are then mounted onto large, tree-like racks, preparing them for the anodizing process. An automated overhead crane system transports the racks, lowering them into a series of chemical pre-treatment baths. The casings move through several large vats, where they are rinsed and etched to prepare the aluminum for anodizing. The automated line continues to immerse the parts in different solutions as part of the multi-stage surface treatment. To achieve a uniform matte texture, the casings are secured in jigs and sent through an automated sandblasting chamber. Once the sandblasting is complete, An operator removes the parts and places them into foam trays for transport to the coloring line. Workers manually dip the casings into a series of chemical baths, a crucial step in the coloring and sealing process. This manual dipping process is repeated in different chemical solutions to achieve the desired color and durability. The process of dipping, agitating, and rinsing the parts is meticulously controlled to ensure a consistent and high-quality finish. After the final coloring bath, the parts are thoroughly rinsed to remove any residual chemicals before drying. A precision laser etches the company's logo onto the top surface of each anodized casing. A robotic dispenser applies a precise bead of sealant into the groove of an internal plastic frame. A worker assembles the sealed top cover with the main body of the case. The newly assembled casing undergoes a careful visual inspection to check for any imperfections in the fit and finish. An autonomous guided vehicle, or AGV, follows a magnetic strip on the floor to transport materials between workstations. In the circuit board assembly area, a worker prepares stencils and bare printed circuit boards, or PCBs. Inside the solder paste printer, a squeegee moves across the stencil, depositing a precise amount of solder paste onto the board's contact pads. The board then moves to a high-speed pick-and-place machine, which rapidly populates the board with tiny electronic components. Next, the board passes through a reflow oven, where controlled heating melts the solder paste, permanently soldering the components in place. At the next station, technicians manually insert larger through-hole components, such as USB and Ethernet ports. After all components are soldered, the motherboards are thoroughly cleaned with a solvent to remove any flux residue from the soldering process. The cleaned motherboards move down an assembly line for further inspection and the addition of smaller parts. A worker carefully applies insulating stickers and labels to the memory slots and other specific areas on the board. And connected to multiple peripherals. Technicians continue the assembly by connecting various daughter boards and cables required for full functionality testing. Once testing is complete, the boards are prepared for final assembly, with each one being scanned and placed into a protective anti-static bag. A machine applies thermal paste to the CPU, and the board is then passed under a UV light to cure the compound. Finished motherboards arrive at the final assembly line, ready to be installed into their casings. A worker carefully inspects a motherboard before passing it on to the next stage of assembly. Each board's unique serial number is scanned before it's carefully packaged for transport to the main assembly line. Back on the assembly line, a worker checks the battery's voltage with a multimeter before applying an adhesive to secure it to the motherboard. The worker then applies a series of insulating tapes and thermal pads over various components on the motherboard. Using a jig, a technician screws together a sub-assembly that will hold one of the internal components. The copper heatsink and fan assembly, which is crucial for cooling the computer, is now carefully attached to the motherboard. A small circuit board containing the Wi-Fi antenna is installed and secured with screws. Technicians install the Wi-Fi card, solid-state drives, and memory modules, and carefully connect the delicate antenna wires. Each assembled unit is scanned, and then technicians install the customer-specified RAM and SSD for final testing. Trays filled with RAM modules and SSDs are kept at the workstations, ready for installation. The mini PCs are connected to a full suite of peripherals, including multiple monitors, to undergo extensive software and hardware testing. During the tests, system software runs a series of diagnostics to verify the performance of the CPU, graphics, and other hardware. After passing all tests, the final internal components, including the SSD cooler and support brackets, are installed. A technician performs one last internal inspection, marking key components with a pen to indicate they've passed quality control. The completed motherboard assembly is now carefully fitted into its aluminum casing, and all internal cables are connected. The bottom cover is then secured with 4 screws using a torque-controlled electric screwdriver. The finished computers are placed on large burn-in racks, where they will operate under stress for several hours to ensure long-term stability. After the burn-in test, a worker performs a final quality check, testing the audio output and microphone input. Each unit is wiped down to remove any fingerprints before a final QC sticker is applied. At the end of the assembly line, workers conduct a final visual inspection of each unit. Another worker gives the unit a final cleaning before it's sent to the packaging line. A worker prepares the retail box, and carefully places a protective film over the device before packaging it. The completed mini PC is placed into its form-fitting tray inside the retail box. The various accessories, including different types of power adapters for international markets, are prepared and placed in the box. Finally, the user manual and other documents are added, and the box is closed. Each finished package is weighed to ensure all contents are present, and then it's fed into a shrink wrapping machine. The sealed boxes are then packed into larger cartons, ready to be shipped to customers around the world.